Hey Gr.12s, we're about to give an overview of question 1.1 for algebra. So question 1.1.1, we have x in two locations. Right now we can see that it's only 2 marks, but that means we don't have to FOIL our x into this bracket over here. We don't need to do this because x is already in 2 locations and we do not have a quadratic equation, which means we can just go ahead, make x equals 0 or x minus 3, the bracket over here, equals 0. From there we take our negative 3 over, we have x equals 3 and we've just earned 2 marks. Question 1.1.2, we have a quadratic equation. We know this because we can see it says correct to 2 decimal places. Okay, so what we have is we already have it in almost the quadratic form. 2x squared plus 1 equals 4x. So if we take the 4x over and arrange it in the format of x squared, then the x, and then the value without the x, we can then get our a, our b, and our c from our quadratic equation because it equals 0. From there, we can just plug in the a, b, and c values correctly into our quadratic equation. There's always 1 mark allocated for this, but no marks allocated for actually writing down the formula on the formula sheet. From there, we just do our calculator work and we solve for x with the positive sign over here, and then x again when we put the negative sign over there. Last step is always rounding off to 2 decimal places as they're mentioned over here. And with that, we just earned 4 marks. Cool. And then question 1.1.3 is usually an inequality. We can see that we have a quadratic equation over here and we have 0 on this side. So what we have to do is open up our 2 brackets, put x over here, x over there, and then find our factor pairs over here from our last term where we have 1 and 3, the only factors of 3. So we're then going to plug our 3 and our 1 in over there, and then we will have to put a negative by our 3 because we have a negative 2 over here. So the bigger value gets the negative, the other value gets a positive because a negative times a positive will give us a negative for the last term over there. Once we're here, we don't just equate it, we write down our CVs where x equals 3 over here, equating it to 0, and x equals negative 1 to satisfy this equation. From here, we put our negative 1 over here, our positive 3 over there, so that they are in ascending order from most negative to most positive, or smallest to biggest. The fact that this inequality does not have a line underneath it means we do not have to color in the dots over there, which means we can just leave open dots, and then from there, the way that we interpret this is, did the crocodile eat the donut or not? In this scenario, the crocodile did not eat the donut, which means it did not go inside its stomach. The crocodile's stomach is over here, which means we draw a line going outwards that way and outwards this way. If it was the other way and the crocodile was eating the donut, we would then be drawing a line just inside, not having any lines on the outside. From there, wherever we drew a line, we can then bring down our x and our x over here, and then the crocodile always eats the thing on the right. So we can put our inequality that way and inequality that way, and then go therefore x is any value less than negative 1 or any value greater than 3. Cool. 1.1.4 is usually some sort of k method. In this case, we have an exponential equation here. So what we can do first is split up this middle term into 2 terms like this, where we have 2 to the power of x times 2 to the power of 2, because that is the same as saying 2 to the x plus 2. From there, what we're doing is we make k equal 2 to the x, which turns the 2 to the 2x into k squared, and then this 2 to the x is replaced with k, and 2 to the 2 becomes 4 over here. So that's how we get the 4k over here. Minus 32 remains the same. From here, we then have a normal quadratic equaling 0, and we can go ahead, open up our 2 brackets, plug k into there and k into there. The factors of 32 that ultimately give us 4 are 8 and 4, and we have a negative 4k over here, which means we need to have a negative 8. The bigger value needs to be negative, and then therefore the 4 is positive because we have a negative here, and a negative times a positive is a negative over there. Once we're there, k minus 8 equals 0 or k plus 4 equals 0, and then we take our 8 over and our negative 4 over. One thing to keep in mind whenever we have an exponential equation is that if we have a negative here, if we were to prime base our 2 to the 2 for our negative 4, that would still not work because 2 to the x cannot equal negative 2 to the 2. So therefore this side of the equation does not work and we draw a line through the equal sign. But what we can do is 2 to the x equals 8 over here after we plugged our 2x back into the k. And then therefore after we prime base our 8, that gives us 2 to the 3. 2 to the x equals 2 to the 3. Therefore x equals 3, and we can drop our like bases. And question 1.1.5, a 4-mark question over here, is usually some sort of restriction. So what we have is an x over here and an x over here, and that's why at the end of this whole thing we're going to have to plug our values back in to see which one doesn't work. Usually one of them don't work. So what we have is this square root here, and what we have to do is take our x over to this side. We do this because we are trying to unhat our square root. We do that by squaring both sides, and just putting a bracket around this side here, the x plus 2, we don't square them individually. So after we've squared this side, we drop the square root over here, and what we do is the SMS method, or we do our FOIL by doubling our brackets. Therefore we get x squared, x times 2 is 2x, times 2 is 4x, and then positive 2 times positive 2 is positive 4 over here. At this stage we can take it all to one side. We take it to the side where the x squared is originally positive, just so that we don't have to divide by a negative, or that we have it in our standard form. From there we have simplified the values as far as they can, like this plus 4 and this negative 2, which becomes a positive 2, which gives us a positive 6. The positive 4 here and the positive 4 there, they just disappear. At this stage we don't have a normal trinomial, but we do have a binomial, and then we can take a common x out of these two things. When we take an x out, we have x in one location and we have x plus 6 in the bracket over here. Therefore x equals 0 or x equals negative 6 is the answer we would have. But if we plug our 0 back into this equation, that makes this statement true. But if we plug our negative 6 back in, it will not equal the same value on both sides. If we plug negative 6 over here, it will not equal 2 on this side. And that will give us 4 marks.